Today we will be talking about integration using integration by parts. Let's say we have the integral of x times e to the x dx. First of all, let's talk about something called LIATE, which is an acronym that stands for logarithmic, inverse trig, algebra, trig, and exponential. This acronym represents the order in which you have to choose which part of the integral to be u and which to be dv. So the integration process becomes easier. We will show how to use it in a second. Now the formula for integration by parts is the integral of u times dv is equal to u times v minus the integral of v times du. Looking at our example, we have x times e to the x. To decide which one will be u and which will be dv, we look at LIATE acronym, where algebra ranks higher than exponential, so we will let u equal x, and dx will be du is equal to 1 times dx, which is just du, is equal to dx. dv will be e to the x dx, so v, which is the integral of e to the x dx, will be equal to e to the x, since no matter how many times you differentiate e to the x, it will stay the same. So in our formula, u is the x, and dv is e to the x dx. Usually the part in the integral that we let equal to u is the one harder to integrate, which is why we use LIATE. However, obviously in this case, even if we let e to the x be u, we can still solve this integral because differentiating and integrating both of these is easy, but in complex equations, LIATE will be very helpful. Now all we do is follow the formula. So u times v is x times e to the x minus the integral of v times du, which is e to the x times dx. Now we have x times e to the x minus the integral of e to the x dx. Now it is very easy to solve, and we get that our final answer is x times e to the x minus e to the x plus the constant, c. Let's look at another example. We have the integral of x cubed times sine x dx. So using LIATE, we know that x cubed is represented by algebra, so a, and sine x is trig, so t. Now looking at our formula, since x cubed is ranked higher than sine x, it will be u, and sine x dx will be dv. Now we define them, so let u equal to x cubed. So du, which is the derivative, will be 3x squared dx. dv is sine x dx, and the antiderivative of sine x is negative cos x. So now we apply the formula to get negative x cubed times cos x minus the integral of negative cos x times 3x squared. We will factor out negative 3 from the integral, so our integral becomes 3 times the integral of x squared times cos x. Now, unlike the first example, this integral is not easy to solve right away. So we will do the integration by parts process again. We will let u equal to x squared since it ranks higher in LIATE. So du will be 2x dx, and dv will be cos x dx, and the antiderivative of cos x is just sine x, which will be v. Now we apply the formula to get negative x cubed times cos x plus 3 times x squared times sine x minus the integral of 2x times sine x dx. We distribute 3 into the brackets and factor 2 from the integral to get negative x cubed times cos x plus 3x squared times sine x minus 6 times the integral of x times sine x. Again, this integral cannot be integrated easily, so we will use the formula one more time. And keep in mind, this may happen a lot when you integrate, where you have to apply multiple techniques or use the same one multiple times. So we will let u equal x, so du will be equal to 1 times dx, which is just dx. dv will be sine x dx, which makes v equal to negative cos x. Now we apply the formula, and we simplify to get negative x cubed times cos x plus 3x squared times sine x plus 6x times cos x minus 6 times the integral of cos x dx. Now we know that the antiderivative of cos x is sine x, so our final answer will be negative x cubed times cos x plus 3x squared times sine x plus 6x times cos x minus 6 times sine x plus the constant c. Let's look at another example. Let's say we have the integral of arc sine x dx. We will write the formula down and know u will be arc sine x. Since there is technically nothing else that it's being multiplied with, it is still being multiplied by 1 dx, which will be our dv. So we let u equal arc sine x, so du is equal to 1 over the square root of 1 minus x squared. Now dv will equal to dx, so v will equal to x. We apply the formula to get x times arc sine x minus the integral of x over the square root of 1 minus x squared dx. Now solving this integral is not straightforward, and using integration by parts may not be the fastest and easiest way to solve it. So we will use substitution. So we will let u equal to 1 minus x squared, which makes du equal to negative 2x dx. And if we isolate for dx, we get du over negative 2x. Now we plug that back into the integral to get the integral of x over the square of u times negative du over 2x. We can see that the x cancels, and we can factor out negative half from the integral to simplify it to become 1 over 2 times the integral of 1 over the square root of u. Now we reorganize our integral to make it easier to integrate. So we will make it u to the power of negative half, and if we integrate it, we will get half times 2u to the power of half, and the 2 will cancel. So we will have x times arc sine x plus the square root of u plus c. Now we sub 1 minus x squared back in for u, and we get that our final answer is x times arc sine x plus the square root of 1 minus x squared plus c. The next example is the integral of ln x dx. So looking at our formula, we know that ln x will be u since logarithmic comes first in Lie8, and dx will be dv. So we let u equal to ln x, which makes du equal to 1 over x dx. dv is equal to dx, which makes v equal to x. We apply the formula and get x times ln x minus the integral of x times 1 over x dx. And we see that the x cancels, so we are just left with the integral of 1 dx. So our final answer will be x times ln x minus x plus c. Let's look at one more example. We have the integral of ln x over the square root of x dx from 1 to 4. First of all, let's rewrite this integral to make it easier to work with. The square root of x is equal to x to the power of half, and if we bring it up beside ln x, it will become x to the power of negative half. Now using Lie8, we know that ln x ranks higher than x to the power of negative half. So u will be ln x, and x to the power of negative half will be dv. So we let u equal to ln x, which makes du equal to 1 over x dx. dv will be x to the power of negative half dx, which means v will be 2x to the power of half. We apply the formula to get 2x to the power of half times ln x minus the integral of 2x to the power of half times 1 over x dx. We factor the 2 out of the integral and divide x to the power of half by x, which has a power of 1. When dividing variables with same base but different powers, you subtract their powers, so 1 over 2 minus 1 will give us negative 1 over 2. So the integral becomes x to the power of negative half dx. Now that the integral is easy to integrate, we integrate it, and we get 2x to the power of half times ln x minus 2 times 2x to the power of half, and we have to evaluate this from 1 to 4. Now we simplify, and we make x to the power of half into the square root of x. Then we evaluate the integral from 1 to 4 by subbing 4 and 1 into the antiderivative and subtracting them. Our final answer will be 4 times ln 4 minus 4.